Assalamu alaikum. It's my pleasure to deliver this talk in such an important meeting, and I thank the organizers for this meeting. The title of my contribution to this meeting is Applications of Daqiq al-Kalam in Modern Physics. In this meeting, I am going to present my proposal for the Kalam Quantum Argument. The Kalam Quantum Argument. But first of all, let me give you an idea, a short description of the problem I am dealing with. In this talk, actually, I'm going to show that quantum mechanics, in the first place, can help us provide strong arguments for the need of a creator and a sustainer. The question of the creator has been discussed in Kalam widely, but very narrow discussions about the sustainer and the importance of describing a sustainer for the universe based on scientific basis is unavailable. I can say it's unavailable. There are some, of course, philosophical. In this talk, I am going to present the scientific evidence for the need for a sustainer to the universe, that is to say, an agency which initiates and controls the changes in the universe. Kalam can provide us with the philosophical framework to realize such a project. But quantum mechanics, as I said, provide the scientific evidence. And here comes the cooperation between Kalam and physics. The Kalam cosmological argument, which was devised by William Lane Craig in 1979, is only part of the story. It's only concerned with, as we will show, with the cause for the presence of the universe, the existence of a cause for the universe. Let me start with an introduction to clarify further my methodology, my approach. The legacy of Islamic Kalam is a novel source for philosophical studies. It contains the views that the Mutakallimun have proposed, their view about the world. The most important part of which is those premises or principles, as it's called, which are related to natural philosophy. But here we should also pay attention to the Kalam methodology. Mutakallimun has left a great legacy in investigating and discussing questions in natural philosophy. Their deduction methodology starts from the revelations, which is the Quran, mainly the Quran, and then through rational analysis they deduce their views about the world. Their methodology of the world can be summarized in the sequence: God, reason, understand the world. This is exactly the opposite for the philosophical approach, which starts from the world through reason to devise, suggest, a picture of the divine and his attributes, etc. This was followed by Greek philosophers. That's why you see Greek philosophy suggesting many gods with almost natural behavior. I have studied Kalam for more than 30 years now. Over these 30 years, I could get a lot of the original contributions of the Mu'tazila and Ash'arites. I found, in fact, that to simplify your research, Kalam can be divided into two sections. And this has been already discussed before by the early Mutakallimun. Section 1, which is concerned with the views and arguments on the theological questions related to the divine attributes, the punishment and reward in afterlife, and other questions related to this field. This section was called by Imam al-Ash'ari and by other Mutakallimun, it was called Jalil al-Kalam. The other section, section 2, which is concerned with views and arguments concerning topics in natural philosophy, like space, time, motion, atomism, causality, and the related questions. This section was also called by Imam al-Ash'ari in his book Maqalat al-Islamiyyin wa Ikhtilaf al-Musallin, and by other early Mutakallimun, it was called Daqiq al-Kalam. So it should be clear, I'm not inventing this Daqiq al-Kalam and Jalil al-Kalam. It was already in the books of the early Mutakallimun. In my study of Kalam, my interest was to investigate their views concerning topics in natural philosophy. And that is what I'm using Daqiq al-Kalam. Since this section is less controversial and more connected with their views about the natural world. In this section, I find valuable thoughts, has sound scientific value actually. In 1994, I already published my first paper about the scientific value of Daqiq al-Kalam, and it is in English. But now I have wealth of investigation in this field. On the other hand, the divinity questions are mostly controversial and have mainly historical value. The English version of my book, Islam and Natural Philosophy, actually this is the new title, Islam and Natural Philosophy, Principles of Daqiq al-Kalam, is now in press and is expected to be available within 2 months' time, inshallah. Well, what are the principles of Daqiq al-Kalam? Again, a very novel approach to study new Kalam is to define the basic principles on which Kalam rests. Maimonides, the rabbi and philosopher, has proposed in his book, The Guide to the Perplexed, very famous book, he proposed that the Mutakallimun actually based their argumentation on 12, what he call propositions, also premises. I mean, the translator of his book, Shlomo Pins, call it premises, 12 premises. But revisiting these premises, I could see that within Daqiq al-Kalam, there are actually only five principles. We can define fundamental principles which are necessary for the questions related to the natural philosophy and the topics or the problems considered. These five principles are atomism, which means that the world is discrete and there is a finitely divisible. Second, temporality, that the world is always, every event in the world is muhdath, is temporal, has a beginning in time. The whole universe has a beginning in time. That's what Mutakallimun has proposed. And the third principle is recreation, that all attributes, all properties of any entity in the world are under in the physical world is under continued recreation. Now, the fourth principle I find is contingency and indeterminism. Philosophers considered the world as necessary, and happening of the events should have necessary causes. Mutakallimun said no, every event in the world is contingent and the world is indeterministic. By the way, philosophically this was classified under the title occasionalism. And I feel that this is a misnomer. It has to change, in my opinion, because if we now take the scientific facts in consideration, we will learn many things about occasionalism that we do not know, or let us say the classical physicists couldn't figure out. The fifth principle is the space-time integrity. Mutakallimun said both space and time constitute an integral entity. No space can exist without time, no time can exist without space, and they have deduced this actually from their own culture in Arabic. The Arabic culture has contributed a lot to these ideas. By the way, these five principles are actually just the opposite to what the Greek philosophers have suggested. But let's ask the question, what would physics say? Until the end of the 19th century, scientists adopted the laws of classical physics. And this classical physics is based on three pillars. The first one is Newton's laws of motion and his theory of gravity. The second is the Maxwell electromagnetic theory and the related laws of optics. And the third pillar is the laws of thermodynamics and the kinetic theory of gases, which is actually based on, mathematically is based on Boltzmann statistics. Classical physics has its philosophical background in the Aristotelian philosophy. How? Well, if you go back and analyze classical physics, you see that it is based on continuity, that is the indefinite divisibility. Second, eternity, no beginning for the world. Third, stability and mutability of the laws of nature, etc. and fourth, necessity and determinism. Events in nature are causally deterministic. And fifth is the principle of space and time are independent, each of other, and they are absolute. These five principles, as you see, is just opposite to what mutakallimun have said. And this is perhaps the reason why not many natural scientists took the views of the mutakallimun in natural philosophy at that time seriously. Because, as I said, until the end of the 19th century, this is the position of the physicist. Now, by the beginning of the 20th century, we have new physics. Many phenomena discovered in laboratories, especially in the microscopic world, in the atoms and molecules, have suggested that we should have new theories, new fundamental theories, to explain these phenomena. And therefore, two great theories were suggested. First is the quantum theory, starting with the Max Planck discovery of the quantization of energy, followed by the Albert Einstein suggestion of the theory of relativity, both special relativity and then 10 years later the general relativity, which is concerned with gravity. This has changed, these two theories have changed tremendously our understanding of the world. Quantum theory tells us that the world is discrete, that's atomic. It also tells us that the world is contingent. Events are not necessary, and this affected actually the concept of causality. If we go in details, we can obviously explain all the basis for that and how it happened. That also it suggests that the world is indeterministic. The action of the laws of nature, or the laws of nature actually, are indeterministic. The laws of nature are the phenomena. In short, laws of physics are what we describe, how we describe the laws of nature. This is also an important difference between the two kinds of laws, which is not clear in the West. The theory of relativity tells us that space-time are integrated and not absolute. And time is intrinsic, actually. It depends on the motion. Even space and time, both are intrinsic and depends on the state of motion of the observer. The theory also tells us, on the large scale, the universe must have a start in time, and that it is finite, but unbound. This is what Albert Einstein's theory of relativity suggests. These two great theories, I emphasize, gives the thoughts of the mutakallimun, the early mutakallimun, great scientific value. I mean, if mutakallimun were at the time or any other time not being accepted by the natural philosophers, now we ought to accept them, because their propositions are in conformity with the basis of modern physics, of the new physics, quantum mechanics, and relativity. And this has to be utilized by those scholars in this conference and in the world to utilize the Kalam as a framework for the philosophy of the new physics, modern physics. Now, quantum theory actually has a mathematical tool called quantum mechanics. This tool enables us to designate. I mean, we have to make it clear what is physics, what is Kalam. I won't say philosophy. I would say Kalam. The idea is that physics and Kalam can produce a worldview, an advanced worldview that enable us understand the world much better than we do now. So quantum mechanics is the mathematical tool. We should care about that. We should care in every details actually. And this enables us to what? To designate the possible states of the physical system. And here I should say, quantum theory tells us that any system, this for example pen, this is black. Yes, it is black. As I see it is black. It's always black. You know. But quantum mechanics tells me that this could be actually have other colors, yellow, purple, blue, green, but only for a very, very, very short time. Most of the time, the color of this pen is black, but in a very, very short, with a very small probability that I can find this pen yellow, for example, or green, but with very, very high probability I find it black. So now the concept has changed. The classical concept of the philosophy of classical physics has been wiped out by quantum theory, and we should take this into consideration. It boils down to say that the world is contingent, and there are many possible states for any physical system. This is a physical system. An electron is a physical system. Mind you, one would say, I never saw the pen, this pen, in yellow or green. Or yeah, you are right, because such features would not show in the macroscopic world. This is a macroscopic body, but it shows in the microscopic body, in the microscopic world, the electrons and atoms and molecules, billions of times changing every second. Billions and billions of times is changing every second. But by the way, the colors which are changing for this pen are also much higher frequency. They are changing at much higher frequency than that what the electron is doing. That's why I don't see the difference at all, no matter how long I wait. While if I wait to see an electron, how it's changing, I could see in the lab the feature, this feature of quantum mechanics, that the electron has many contingent states. Well, quantum mechanics tells us also that the happenstance of any physical phenomena is probabilistic. This certainly has an impact on the concept of causality, but this is not our discussion here. I will concentrate on the main topic, which is the need for a sustainer. Quantum mechanics cannot tell us when such an event, say the yellow pen, will appear. it's always black. But it can tell us, quantum mechanics tell us, the probability of having the yellow or the green color. See the point? It cannot tell us, quantum mechanics cannot tell us at which time would any of these probabilities will be affected. It can only tell us the magnitude of the probability. Just an example I gave you an example about I gave the example about the pen. But another example would be, say, if you hit a wall, a brick wall, with a rubber ball, you don't expect that the ball will go through the brick wall, because the stiffness of the wall is much higher than the kinetic energy, we say, of the ball. However, electrons trapped in a crystal with energy less than the stiffness of the walls of the crystal.
This we can see in the laboratories. Actually, without such a phenomena, leaking electrons, all your electronics will not work. Your mobile phone will not work if this phenomena did not exist. And this is how semiconductors actually are working. Therefore, philosophically, we should allow for the possibility that the rubber ball can get through the solid brick wall, even if its energy is very, very, very low. Yes, we have to emphasize that such an event has a very, very low probability. Maybe you have to wait for 1 billion years, or you hit the wall a trillion times with the ball until once it could go through the wall. Philosophically, this is important.
The question is, when such an event happens? The answer is, we don't know. Then I'll put the question again. Who is determining the occurrence of events in nature? Events have different probability, as I said. Some has low probability, some has high probability. But even very low probability events can occur. Is it possible that one day we may discover the law which determines the occurrence of events, which tells us which probability will happen at which time? The answer is no. There can be no such law. Why? Because if it will be a law of nature, then it would be also a law which needs a determinant. It will be probabilistic. There is the result of such law, it will be probabilistic. And if it is probabilistic, it will need a determinant. And if and then we may add ad infinitum. For each case, we have another law which is defining or determining the event, and so on. Therefore, laws of nature must be working under the auspices of a non-physical agency, an agency beyond our space and time and beyond our physics. As I said, simply because there is no law which tells us which probability will happen at which time, and there can't be such a law, because laws of nature are probabilistic. Even if one says, but the laws of physics are deterministic, correct, they are deterministic in their differential equations forms, but the result of the action of the laws of physics, which is the laws of nature, are probabilistic. Acknowledging the fact that there is now the Kalam cosmological argument suggested by Craig. This is actually only concerned with arguing for a cause for the universe. That's all. It doesn't tell us how the universe was created. It doesn't tell us how the universe is sustained. Several authors and philosophers like Winton Smith and Adolf Grunbaum have placed serious philosophical criticism to the Kalam cosmological arguments. I find a better substitute, a better extension, a better, more general framework is the Kalam quantum argument. Here I am utilizing what I already have explained to you about quantum mechanics and the nature of quantum world. And I can summarize this Kalam quantum argument saying that events in nature are probabilistic according to quantum mechanics. Probabilities need determinant to be realized. This could be premise number 2. Then we say such a determinant cannot be part of the physical world since it would be an event by itself, which means that it will be probabilistic by itself, so it needs another determinant, etc. Therefore, the determinant must be beyond our physical world. The details associated with this argument provide a mechanism for the sustainment of the universe. And the argument is actually an interplay between Kalam and physics. Definitely we need much efforts by researchers and scholars to formulate this argument in the best shape, in the best way. What are the bases for the Kalam quantum argument? I think you have already realized, or you got the idea, that the Kalam quantum argument is construed from 2 sources: quantum mechanics and Kalam. But where in Kalam we can find such a basis? It is in the principles of recreation and the principle of contingency and indeterminism. These 2 principles are providing us with the, if you like, call it philosophical basis for the Kalam quantum argument. The principle of recreation, by the way, on its own can explain several aspects of quantum mechanics. Several paradoxes in the present quantum mechanics can be explained by the proposal of recreation on its own. These are actually published. I have published this work a long time ago, more than 10 years ago. Recreation, a possible interpretation of quantum mechanics, in the proceeding for the conference on matter and meaning, which is published by Cambridge Scholar Publishing and was edited by Michael Fuller from the University of Edinburgh. So there is a paper there, and I have another paper which is with more scientific, detailed scientific content. It's also in archive, and I've not proposed my theory, full-fledged theory about recreation as an interpretation of quantum mechanics. I haven't yet proposed it in the full scale or as a full-fledged theory. Now I hope that you would appreciate the Kalam quantum argument, and I would welcome any collaboration, any discussion, any extension, any question about this subject. Because once we do that, once we succeed in presenting the Kalam Quantum Argument, this will be then a great success for the utilization of Kalam in modern science and modern philosophy. That's what I am aiming at. In fact, my project to revive Kalam is not bound to Daqiq al-Kalam only. My idea goes further to consider at a later stage reviving Jalil al-Kalam or a new Jalil al-Kalam, because in the Islamic world, and I believe whole world, need a new philosophy, a new way of understanding the natural world and the human world. And this can only be provided by, in my opinion, the Kalam philosophy. Because this philosophy is using aql, the intellect, and is respecting the divine, using aql, the intellect, to analyze the nature and discover the laws and conclude the results. What prospects we have? We have many prospects, actually. We do in this field. That's why I call. And I am thankful to the Turkish universities for adopting or for at least discussing my ideas over the last 10 years or more. We need to move forward, I would say, from the state of stagnation in our academic studies of classical Kalam. The new approach I have been suggesting for years now should be widely discussed, I feel, and should be implemented. In fact, we need to establish a school for a new Kalam, and I'm thankful to Professor Shalabi for encouraging this direction, and Dr. Mehmet Bulgin, Ilyas Shalabi and Mehmet Bulgin were really backing this approach, and I am ready to collaborate with any other colleagues, especially in Turkish universities. The principle of recreation, as I showed, is very rich. The quantization of time, according to Mutakallimun, is another source for physical as well as philosophical contemplation, which can give us clearer understanding of the world, and this may explain the existence of a block universe. In a recent scientific paper we published about the quantization of time and the quantum time, I have already showed, with two other colleagues contributing to this paper, I have already showed that the universe could be a block universe. That is to say, the present, past, and future are all in the same, simultaneously exist in this universe. And this is, by the way, the Islamic conception of time, that all the events are there. It's only unfolding. Anyway, this is another subject, could be another talk. New presentation of Kalam can provide us actually with a full-fledged theistic philosophy of science. There are many questions that can be explained, can be discussed within such philosophy that restores the proper position of a human being in this world, with all the good values that we have learned through our experience, spiritual as well as physical experience. Thank you for listening, and I hope that I have made my point, and certainly I will find some feedback. Thank you.